first question. So the question is, which command is run on an FTD unit to associate the unit to an FMC manager that is at IP address 40.85.179.197 and that has the registration key Cisco 123. Here comes the second question, which is, what is the result of enabling Cisco FTD clustering? Let's look at Firepower clustering first to answer this question. Hello everyone, and welcome to today's online class presented by 591lab.com. This is Cisco Certified Network Professional Security, Securing Networks with Cisco Firepower, which we call as SNCF 300-710. First of all, let me tell you more about 591 Lab. 591lab.com, pronounced as 591 Lab, is the top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at 591 Lab is to provide our clients with exceptional exam preparation experience for certifications in Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. In our today's agenda, we will be covering two topics, which is Firepower registration and Firepower clustering from the Securing Networks with Cisco Firepower exam objectives. These concepts will help you prepare for the Securing Networks with Cisco Firepower certification exam. Now, let's quickly deep dive into our first question. So the question is, which command is run on an FTD unit to associate the unit to an FMC manager that is at IP address 40.85.179.197 and that has the registration key Cisco 123. Now, let's talk about Firepower device registration design first. An FTD supports two main management modes: off-box via FMC, also known as remote management; on-box via Firepower Device Manager or Cisco Defense Orchestrator, also known as local management. In the case of remote management, the FTD needs first to register to the Firepower Management Center that uses a process known as device registration. When the registration is done, the FTD and the FMC establish a secure tunnel called SF tunnel. From a design point of view, the FTD and FMC can be in the same L3 subnet or be separated by different networks. Now, what all information is exchanged through SF tunnel when the FTD is registered with FMC? So we have appliance heartbeat, which will give us the healthy status of the FTD device to the FMC. Then we have time synchronization, which will synchronize the time between the FTD and FMC so that the logging event should take place correctly with the appropriate timestamps. Then we have the events, which could be connection events, IPS, IDS, file, SSL, and others. We have the malware lookups, health events or alerts, user and group info, which all are exchanged through this SF tunnel. Then we have FTD HA state info and FTD cluster state info, which got exchanged towards the FMC from the FTD. Then we have security intelligence info and events. We have threat intelligence director info and events. So these all are the logging parts which you can see on the FMC. We can also see the captured files, the network discovery events, the policy bundle, the software upgrade bundles, the software patch bundles, the VDBs, and the SRUs. The upgrade files are also pushed through the SF tunnel towards the FTD via FMC. The SF tunnel uses TCP port 8305. In the backend, it is a TLS tunnel. So the communication that has been happened over port 8305 using the TLS SSL connection. Now, whenever the connection is established by the SF tunnel between FTD and FMC, we have two channels established. One is control channel and the other is event channel. Let's look at the registration basics on the FTD CLI. On FTD, the basic syntax for the device registration is configure manager add. We have to put the FMC host then the registration key, and then the NAT ID, which is an optional. The FMC host can be host name of the FMC, IPv4 address, IPv6 address, or we can use don't resolve. The registration key is a shared secret alphanumeric string used for the device registration. Only alphanumerics, hyphen, underscore, and period are allowed. NAT ID is also an alphanumeric string used during the registration process between the FMC and the FTD device when one site does not specify an IP address. Specify the same NAT ID on the FMC in order to proceed with the registration. Hence, the answer is D, which is configure manager add 40.85.179.197 Cisco 123. Here comes the second question, which is what is the result of enabling Cisco FTD clustering? Let's look at Firepower clustering first to answer this question. Cisco FTD clustering is a technology that allows you to group multiple Firepower threat defense together to act as a single logical device. This can provide a number of benefits, including increased scalability, redundancy, and performance. One of the primary benefits of Cisco FTD clustering is scalability. By clustering multiple FTD devices together, you can increase the overall throughput and capacity of your security infrastructure. This can be helpful for organizations that are experiencing high traffic volumes or that need to support a large number of users. Another benefit of Cisco FTD clustering is redundancy. In a cluster deployment, if one of the FTD devices fails, the other devices in the cluster can take over its traffic and security policies. This helps to ensure that your network remains protected even if there is a hardware failure. Finally, Cisco FTD clustering can also improve performance by distributing traffic across multiple FTD devices. You can help to reduce latency and improve overall network performance. Let's look at the traffic flow for the new TCP connection taking place in Cisco FTD cluster. The client initiates the TCP connection by sending a TCP sync packet to the TCP port on the server it wants to connect to. The FTD cluster receives the TCP sync packet from the client. One of the cluster members takes ownership of the connection and adds a TCP sync cookie to the packet. This cookie helps the cluster track and manage the connection during the handshake. The FTD cluster forwards the modified packet containing the client's sync and the FTD cluster sync cookie to the actual server outside the cluster. The server responds with a TCP SYNAC packet to initiate its part of the handshake and acknowledge the client's sync. The FTD cluster intercepts the server's SYNAC packet and redirects it back to the client through a different member of the cluster, which acts as the flow director in this stage. The client receives the redirected SYNAC packet from the flow director and sends back a TCP acknowledgement to acknowledge the server's sync. The flow director receives the client's acknowledgement and updates the flow ownership information within the FTD cluster based on the TCP sync cookie embedded earlier. It then becomes a flow forwarder for the established connection. Subsequent data packets between the client and server can now flow directly through the flow forwarder within the FTD cluster without further intervention. Now, let's look at the traffic flow for the new UDP connection that initiates through FTD clustering. The client initiates a connection attempt by sending a UDP packet or a packet resembling a UDP packet to the FTD cluster targeting a specific service or a port. The FTD cluster receives the packet. It performs a lookup to identify the appropriate cluster member to handle this connection. If a matching entry is not found in the flow table, the cluster queries the director to determine the owner. The director acknowledges that it doesn't have an existing entry for this specific flow. The client might retransmit the packet multiple times if it doesn't receive a response within a timeout window. These retries are depicted by the client label. The FTD cluster selects one of its members as the owner for this new connection. It updates its flow table and transmits the packet to the server outside the cluster. The server processes the packet and sends its response directly back to the client. The client receives the server's response packet. The FTD cluster, upon observing the traffic flow, updates its flow table to reflect the now established connection. The member that initially took ownership becomes the flow forwarder for this connection, facilitating subsequent data exchanges. If the client initiates additional requests to the server using the same service or port, the FTD cluster might choose to redirect those packets through the director for further processing or inspection before forwarding them to the server. This adds an extra layer of control but can potentially introduce latency. The server's response packets are then routed back to the client through the designated flow forwarder within the FTD cluster. Now, let's look at the scenario where the owner failure occurs. The text says owner fails. This indicates that the member of the FTD cluster that was designed as a flow owner for a particular connection is no longer available. This could happen due to various reasons like hardware failure, software crashes, or being removed from the cluster for maintenance. The failure of the flow owner disrupts the communication flow. Since the flow owner was responsible for managing the connection between the client and the server, established communication might experience the below issues. One of them is packet loss. Packets that are sent from the client or server might not be delivered due to the disruption caused by the flow owner failure. Connection stalling is something which ongoing data exchange between the client and the server might halt unit until a new flow owner is assigned. The client not receiving a response from the server due to the flow owner failure might initiate the retries. Packet load balancer to another member by sending that packet again. This is the normal behavior for clients to handle potential network delays or packet losses. Hence, if the master unit fails, all the VPN connections will be dropped and VPN will be unavailable until a new master is elected, potentially causing a temporary security gap. Hence, the answer is C, which is site-to-site VPN functionality is limited to the master unit, and all the VPN connections are dropped if the master unit fails. Here are the other answer choices and why they are incorrect. Option A, for the dynamic routing feature, if the master unit fails, the newly elected master unit maintains all existing connections. This is not necessarily true. Depending on the dynamic routing protocol being used, some connections may be dropped when the master unit fails. Option B, integrated routing and bridging is supported on the master unit. This is true, but it is not a unique benefit of Cisco FTD clustering. Integrated routing and bridging can also be used on standalone FTD devices. Option D, all Firepower appliances can support Cisco FTD clustering. This is not true. Clustering is only supported for the Firepower Threat Defense devices on the Firepower 9300 and the Firepower 4100 series. You can include up to 16 nodes in the cluster. For example, you can use one module in 16 chassis or two modules in 8 chassis, or any combination that provides a maximum of 16 modules. Firepower 4100 supported for up to 16 nodes using clustering with multiple chassis. Thank you all for attending today's class at 591 Lab. We hope you found this material informative and helpful. Remember, practice is critical to mastering any new skill. So review the course content and keep practicing with 591 Lab help and support. If you have any questions or concerns, please don't hesitate to contact us. We appreciate your participation and look forward to seeing you in our future classes. Have a great day ahead.